Well, thank you guys for joining. My name's Jack Moreland. I'm a research scientist at Purdue Northwest. I helped run the program last summer, and I'll be helping run things again this summer. I'm going to go through just a little bit of overview for the program. The email included some information, so I'm not going to belabor too many points, but I do want to leave some time for you guys to ask any questions that you have. All right. This project is called Research Experience for Teachers. It is funded by the National Science Foundation. It has two main goals. One is to provide research experiences for teachers. And then the second goal is to take that experience from the summer and transfer it to your students. And so the broader goal is to increase student STEM interest, knowledge about STEM careers, those sorts of things. And this program is specifically to do that by giving you guys the ability to do research yourself, so you have more of that firsthand knowledge. At CIVIS is the name of our center at Purdue Northwest. We're a simulation center, and so we do a lot of simulation and visualization activities. Some of that is through engineering type of simulation, mechanical engineering, that sort of thing. The other side is doing more visualization things, 3D, virtual reality, and those sorts of things. When we say research, really what we're doing is we're doing an extremely condensed version of a PhD program. So doing a similar type of PhD research project related to industry. We have a lot of ties at our center to steel industry, but also power industry and various others located around Northwest Indiana. And what we do is we basically, when I say it's an extremely condensed version, we teach you guys and then have you go through each of these main steps. So doing a literature search, identifying a specific problem, coming up with a research plan to tackle that problem, teaching you guys the skills that you would need. We also have a handful of grad students that are going to be working alongside teachers. Depending on the complexity of the problem, we want to make sure that this is something that everybody's able to tackle and complete within the 6 weeks of the summer research. Doing the research itself, analyzing the results, and then we want to have you guys already be ready to implement this in the classroom. So one of the outcomes from the summer is coming up with a lesson plan and a good plan for bringing your research experience into your classroom. So 4 summer outcomes. So the research itself, the education module or lesson plan, the school year implementation plan. This is basically just having a rough idea what time during the year you would plan to fit this into, and if it would apply for certain standards. And then there will be a end of summer presentation that each teacher would make as well. We don't have a strict format for how lesson plans need to look. Everybody has their own style, and so we don't want to reinvent, especially if you are already comfortable in things. We want things to fit into your class. But a sample format would be having a learning objective, coming up with a bell ringer or an introduction to tie it into what the students are going to be familiar with, and then going through I do, we do, you do, and then finishing with a reflection and then do an assessment. Some of these images on the screen are, these are both projects that teachers worked on last summer. And so we had teachers from a variety of backgrounds. We had some science, we had some PLTW. We also had various others. We had environmental, we had math. And so we are looking for ways to tie these existing research projects that are ongoing with companies that Purdue Northwest is already doing, and tie the curriculum that you guys would already be covering into these projects. And so these are going to be very customized for something that would fit into your classroom. That's the quick overview. And so now I can definitely present and give more detail, but let's maybe open it up to questions and have a little bit of discussion. So from what you guys have already seen in the email and what we just covered, what questions do you have?
It was pretty vague about, understand it's like the 5 or 6 week program, and it said, or 6 week program, and it said it was hybrid. So what does that mean? How often will we be on campus? What will we be doing? How does that actually look?
Yeah, so to some extent, so we have a basic guideline, but to some extent, it's going to be worked out between you and your mentor. So the project you'll be working directly with a faculty member at Purdue Northwest campus. It's 6 weeks long, so that part's non-negotiable. How many weeks or how many days per week? Right now, it's looking like it's going to be 4 days in person and 1 day just at your discretion. So the campus facilities are going to be available to you every day, but some of the schedule is going to need to be worked out directly between you and your mentor. And then the schedule itself would be something in the neighborhood of 5 hours per day. And again, that would be worked out a little bit between you and your mentor. The exceptions are the first week, we want everybody to have the same experience. And so there's going to be a lot of big group activities happening during week 1. And then there'll be some big full group concluding activities during week 6. But those middle weeks, that's where there's a lot more flexibility. Did that answer your question?
Yeah. And then I'm looking here, it says Mike Brackner, early November. What's that?
So sorry, I had a question from a previous presentation. I forgot to go in and modify the slide.
Oh, okay. Okay.
This is, let me actually just go through, see what else is covered here.
So this will be concluded July 22nd.
That's right. Mm-hmm.
Okay. And then it also says, so when you said like final presentation, so we would be presenting in that week 6, I'm guessing like our lesson plan or something, what our plans are to do for the classroom. Okay. I didn't know if it meant like we're going to reconvene after it's been taught and come up with analysis. That's what.
Right. So the bulk of the project of this NSF project is happening during the summer, but we do have a couple planned activities throughout the school year just to basically keep up with you guys, offer any help that we can. So the previous summer's group is still going on now, and so some of the teachers implemented as early as December. Or early November, in this case for Mike. And then other teachers have not implemented yet. They have plans either later in March or early April, and that's just up to everybody how it fits in best with your yearly plan.
Okay.
Let me see if I got anything else here. So this schedule is actually from last year's, but to give you an idea of what the schedule would look like, we plan out these big group activities like orientation, and then we had set it up as mentor time, research time, and these guys are very much more personalized. So we follow the format of every morning we would have a check-in and have everybody basically touch base and get some face time. But then once you guys get settled in, you've learned how to use the software if you're doing a software project, or you have a good sense for how to do the research, the actual research, then we leave quite a bit of time up to you. So you can either be using the lab. We have a couple planned field trips out to a couple like steel mills or other places related to the research. And then times with the graduate students also. What ended up happening last year was we had one grad student for each project. And so some of the projects had multiple teachers working on them. These are things that will be figured out early on in the summer. So we want everybody to have enough of an idea what's going to happen during the summer, but some of those details aren't going to be figured out ahead of time. They're going to be sit downs between you and your mentor and the grad students during that first week.
Another question. So are we coming with an idea for research, or we're coming with our certain skill base and we're going to be put into an area of research?
So we have a number of projects that are already happening. And so it'll be matching your class, your skills, and your interest with this set of projects that are already in process.
Okay, that takes a lot of pressure off.
Yep. And so some of the creative part will still need to be something that needs to be figured out, which is so science class. There could be many different ways that you could map the research project into standards that you're already covering sometime during the year. Same thing with PLTW. It's just a matter of going through. Probably by midway through the first week, you'll have a good sense of what the possibilities are with each research project, and then you'll have a better sense of which one, which standards you'll want to map it to.
Got it.
Let me pull up. There is a website. And on the website, we do have a list of the projects. And so we have 4 possibilities right now. So they are performance and these project titles are kind of long, like what you would see in an academic paper, but I'll boil it down for you. Performance analysis of a natural gas combustion in a blast furnace. And so if we expand this, there's some detail, but essentially this is a project with the steel industry where it has a lot to do with combustion inside of one of these gigantic building-sized furnaces. And so this one, there's well, let me put it through the lens of teachers last year. So last year we had a teacher do a chemistry tie-in, and so they tied it into some chemistry part of their school year. Another teacher did environmental, looking at what kind of emissions might this furnace make into the environment, and then another teacher did more engineering type of project for this one. The second one, energy efficiency of a steel slab reheat furnace. So again, kind of a wide variety of things. So in this case, there's combustion, there's some materials that are going into it. Structural and fatigue analysis of an overhead crane in a steel plant. So this one is more, I'd say, traditional engineering. So not so much combustion and gas emissions, but rather this one is looking at stress, fatigue. So if you imagine like bridge building type of activities, it's that sort of thing, except with some industrial equipment. And then project 4, investigation and cause and prevention of incidents through safety training. So I'm actually going to be mentor for this project, and so I know the most about this one. But really, this is using video game technology to teach safety training. So this is applicable to lots of different industries. But essentially, we're going to teach using a software called Unity 3D and teach how to use game technology to do educational things. So Jackie, what are your thoughts so far? Do you have any questions?
No, really, I just needed, was seeing what it was all about. So, okay. Thank you.
Yeah. And Kelly, do you have any other questions?
No, I mean, well, I guess, I have a question, like, why bring high school teachers into this?
Yeah, so going back to the big goals. So this is, the big goal is for the benefit of teachers to help inspire students. So these are active research projects in, some of them are steel companies. One of them is power company. And these are jobs that exist now in Northwest Indiana. One of the big things is we see a lot of students, they are not going into research type jobs. And so we want to show them, hey, when a lot of times if students hear the word research, they may not really know what that means as far as a job. And so we want to get that info to them through you guys. So have you both build some skill set. So we'll be teaching you how to use some of this software to do some of this research. You'll also learn about some of these companies that are that have these research jobs here in Northwest Indiana, and then the hope is you'll both teach your students some of the skills or get them interested in some of the things that you're doing, but also you'll have some firsthand knowledge about these jobs that both you probably didn't know existed and the students may not have known existed.
Okay. About how many teachers do you take on each summer?
12 each summer.
Got it. So in this case, would it be 3 per project?
Yep. And it's not always exactly 3. So we do a little bit of skill matching, and so last summer we ended up having 4 on project 4. I think project 2 only had 2 teachers, and so we mix and match a little bit just to make sure that it fits.
Okay. And the typical day, it looked like your schedule, a typical day is like 9 to 3.
Yeah, roughly. We are still making some changes on the schedule. One of the comments was from last summer is teachers wanted a little bit more flex time. And so last summer we did 5 days a week, 9 to 3. And so that's why I mentioned we're adjusting. It's probably going to be 4 days a week, 1 day flex time, and then the number of hours per day we're probably going to be adjusting as well.
Okay. Okay. Interesting. Appreciate it.
Yeah. Do you guys understand the application process? It's also here on the website, but I can recap it for you. Essentially, there's a couple things you need to put together and then email. And so these will be due by March 24th. So you got a couple weeks left. But a resume, key thing here is we want to see what classes are you teaching. Or what classes do you expect you'll be teaching next year, since that's when this would affect your students. 2, a letter of support. This doesn't need to be anything detailed. We don't want to surprise principals or other people at your school next year if you're going to be working in a couple days or a week of activities for your students that they didn't know about. And then 3, personal statement essay. Up to 2 pages. Again, this doesn't need to be anything huge or daunting. We just really want to kind of understand what is your understanding of how this might fit into the project. Do you have ideas of which of these 4 projects you would already be interested in? Those sorts of things. And so then you would email those all to this email address here, civis@pnw.edu.
Just like 1 email, 3 attachments is what you're looking for.
Yep.
Okay.
Good, thank you.
Yeah, sounds great.
Absolutely.
Good information. Yeah.